our first example. Okay, so we have calculate the pH of a solution with an H concentration of 5.6 times 10 to the negative 3 molarity. Okay, so just a reminder, brackets, that means concentration. Okay, and I kind of gave you that reminder right there as well. Okay, so this is what we're given. So I'm going to underline what we're given. I'm going to circle what we're looking for. We're calculating the pH. Okay, so I'm going to go ahead and look at my little square. Okay, I'm starting right here. Starting right here, I want to go to pH, so I'm going to go across to pH. That means I'm following the arrow going to the right down here. So it says pH is equal to the negative log of whatever that concentration was, right? So we're going to go ahead and have pH is equal to negative log, and then we can put our concentration into that. 5.60, and I'm going to say E negative 3. So go ahead and type that into your calculator if you'd like to follow along with that. All right, so negative, remember the one at the bottom, log, and then we're going to say 5.60. I'm going to go ahead and hit a second E, and then negative 3. Okay, and I'm going to push enter. And so the answer that I got was 2.25, right? And yours, if yours is in scientific, has an extra little spot right there. As long as it says times 10 to the 0, you don't have to include it. Otherwise, include it, all right? So I got 2.25. We'll just go to 2 decimals. There's a certain way that we're supposed to be rounding, but don't worry about it. So this will be 2.25. All right, so my answer is that, and then is it an acid or a base? It is an acid. Which scale did you look at? pH, exactly. So we look at the pH scale, we're seeing that it's over here. So we have 2.25, and that is an acid. Is it a stronger acid or a weaker acid? Stronger. Okay, so stronger acidic. Or stronger acid. All right. Okay, next one. Calculate the H concentration of a solution with a pH of 2.80. So we have 2.80 given to us. We're calculating for the hydrogen concentration. Okay, so we're going to go ahead and look up here at the top. We're starting at pH. We're going this direction because we're heading to the H. So we're going to follow the arrow going that direction. We have 10 to the negative pH. So what we're going to type in, we're going to have 10 to the negative, and then we're going to have our pH, which was 2.80. So on our calculator, we're going to use that second log. Okay, and the negatives do matter. Remember, it's about moving that decimal. We're dealing with smaller concentrations, okay? So second log, and then I have negative 2.80, and I get this as my answer. So you have 2 options. You can write that as your answer, right? So the 0.00184, okay? Or 185, whatever. But me personally, I'm going to put it into scientific because I don't like writing a bunch of zeros, and it's going to get worse. So I'm going to go ahead and switch my calculator over using that little method I just showed you. Second, DRG. I'm going to switch it over to scientific. I'm trying to make that so you guys can see it. There you go. Scientific, push enter. Now it's set up for me 1.584, so I'll just do 1.58 times 10 to the negative 3. Okay? And then don't forget your units. You're either putting a bracket around it or you will put a capital M, molarity. pH does not have units, so you don't need to write anything there. Okay, is this an acid or a base? Me personally, I can't tell by looking at the molarity. I mean, I could probably figure it out, but where else could I look? That's probably a little bit easier to figure it out. The pH, yeah. So we were given 2.80, right? So 2.80, is that an acid or a base? That is an acid. We're on the pH scale. Is it stronger acid or weaker? Stronger acid. Okay. All right, pOH calculations. So nothing is changing. They're all the same calculations, hence why I said it's really not difficult, okay? It's a matter, though, of knowing what your answer is telling you. So calculate the pOH of a solution with an OH concentration of 4.30 times 10 to the negative 10. So we have that OH concentration. We're solving for pOH. I'm just going to speed up just a tiny bit. So we're starting here now. We need to get to pOH. So we're going to go to the right. That means we're going to use negative log. So I'm going to have negative log, and then I'm going to have 4.30 E negative 10. I'm going to type that into my calculator. What did you guys get? Yep. Well, not times 10, times 10 to the 0, which means times 1. So yeah, we'll just leave that part off. You're good. All right. That's a good point, though. I'm glad you brought that up. So if you do have yours in scientific, it does have this part at the end, okay? Anything to the 0 power is the number 1. That's it, all right? If we accidentally leave it times 10, then we just move that decimal, and we just change this to be 93.6. So you don't want to do that, all right? Just make sure if you're leaving it in scientific and you're going to write that extra part, you write exactly what's there, which is times 10 to the 0, because that does mean the number 1, and technically it's right, okay? So 9.37 is our answer, okay? And if you ever you're not sure, you're not positive, then put it back to normal just for your answer, okay? All right, 9.37, and is that an acid or a base? That is an acid. Is it a strong acid or a weaker acid? This is weaker acid. So, big thing to remember on this, it was pOH, which means you can't look at the pH scale. You have to look at the pOH scale, okay? All right, so here, calculate the OH concentration of a solution with a pOH of 3.5. So we're going to start at pOH here. We're going to head this direction to OH concentration. We'll have 10 to the negative pOH. So 10 to the negative 3.50. And with that, we get 3.16 times 10 to the negative 4. Molarity, okay? Which is the same thing as me saying 3.16 and then sending that decimal 1, 2, 3, 4 times to the left. So your calculator might have said that, and that's fine. I just don't like writing zeros, okay? Alrighty, so you've now gotten to see all of those, so let's just make sure that we've got this. Let's do the very last one. It says, what is the pH of a solution that has a pOH of 5? So, looking up at the square, because you can still use the square, pOH is right here, pH is up here. You're going to use the arrow pointing to that. It says pH is equal to 14 minus, which is the same exact calculation that we had done in the previous part, right? So pH is equal to 14 minus 5 again, which we know is the number 9. But now, is this a acid or a base? You sure? No, it is. It is. It's a base. It should be, but is it a weak base or a, yes, weaker base. And we do have to say the part just because it's a spectrum, all right? And that's why I've been putting the weaker, stronger kind of stuff. All right, so that's all you need from me about the calculations, okay? Let me stop this thingy real quick.